These are your notes for Unit 10, Day 4 of Algebra 1. If you would like to see the warm-up, review question, or any homework questions we covered in class today, just look at the finished notes. So today we are going to use our knowledge of quadratic equations, so equations of degree 2, to be able to graph those functions called quadratic functions. So we'll be able to graph them if they're in the form y equals ax squared. And we'll be able to graph them if they're in the form y equals ax squared plus bx plus c by finding the vertex of the parabola and the intercepts, the x-intercepts of the parabola. All right, so parabolas. Parabolas are going to be the graphs of quadratic equations or quadratic functions. So again, if you have a degree of 2, then the graph of your equation is going to make a parabola. So it's either going to make a parabola that opens up or it's going to make a parabola that opens down. And so notice we have some key features of your parabolas. So in a parabola, again, they kind of make U shapes. You've got some key features. If the U shape opens down or it looks like a frown, that top point is called the vertex. And so in this case, that vertex would be a maximum point on the parabola. It'd be the highest point on the parabola. Where the parabola crosses the y-axis is called the y-intercept, just like in a line. And where it crosses the x-axis, so these 2 points, are going to be called the x-intercepts. And remember, how do we find x-intercepts and y-intercepts? Well, to find x-intercepts, you let y equals 0, and then you solve for x. And to find the y-intercept, remember, you let x equal 0 and then solve for y. The line that divides the parabola in half, so that vertical line that will divide the parabola in half, we call that the axis of symmetry. And notice the axis of symmetry is always going to cut through the vertex. Okay. If the parabola opens up, or it looks like a happy face, it has the exact same features. So the vertex is that low point. So if the parabola opens up, then the graph will have a minimum value or a lowest value. Where it crosses the x-axis are called x-intercepts, and where it crosses the y-axis is called a y-intercept. And that line that divides the parabola in half is called the axis of symmetry. All right, so let's look at how to graph these. So if you're going to graph y equals ax squared, so it's just x squared, there's no other terms. Let's see what it looks like. So we can make a table of values. So if y is just equal to 1x squared, if I plug in -3 squared is 9. Plug in -2 squared is 4. Plug in -1 squared is 1. 0 squared is 1. 1 squared is 1. 2 squared is 4. 3 squared is 9. So let's graph those points. So 0, 0, 1, 1, 2, 4, 3, 9. -1, 1, -2, 4, -3, 9. And so notice if you connect those dots, you have a happy parabola, or a parabola that opens up. So notice in this parabola, the vertex is down here, and it's a minimum, and it would be the point 0, 0. That is also the x-intercept and the y-intercept, because that's where the graph crosses both axes. All right, what happens if I have -2x squared? Well, if I do this, remember that's -2 times x squared. So you're going to do the exponent first and then multiply by -2. So this would be, if I plug in -3, I get -18. If I plug in -2, I get -8. If I plug in -1, I get -2. If I plug in 0, I get 0. If I plug in 1, -2. Plug in 2, -8. Plug in 3, -18. So if I go to graph this, I get 0, 0, -1, -2, 1, -2, and then 2, -8, -2, -8, and then the 3's would be below where the graph would be. So notice if I connect those, again, I have a parabola. This time the parabola opens down, and it looks a little bit narrower than the parabola that I had on the left side. So the vertex of this parabola is also going to be 0, 0. So what are some differences in the two equations? Well, in this equation, I have y equals 1x squared. and it's a positive 1. So a was positive 1. And notice, if a is positive, the graph is going to go open up towards the sky. And in this second example, I have y equals negative 2x squared. So a is negative 2. So if a is negative, the graph is going to open down, or it's going to look like a frown. So if a is negative, the parabola looks like a frown, or it's a sad face. If a is positive, the graph opens up, or it looks like a smile. All right, why don't you guys take a minute and see if you can graph y equals negative 1/2 x squared or y equals 3x squared using the table. All right, so if you plug in negative 3, remember, do the exponent first, and you would get negative 9/2 or negative 4.5. If you plug in negative 2, you would get negative 2. If you plugged in negative 1, you would get negative 1/2 or negative 0.5. Plug in 0, 0. Plug in 1, negative 0.5. Plug in 2, negative 2. And plug in 3, negative 4.5. So we have 0, 0, negative 1, negative 0.5. 1, negative 0.5, 2, negative 2, and negative 2, negative 2, and then 3, negative 4.5. So 1, 2, 3, 4.5, and negative 3, 4.5. 1, 2, 3, 4. And so if you connect those, you've got a parabola. It looks a little bit wider than that normal parabola, and notice it opened down because I had negative 1/2, so a was negative 1/2. So it looks a little bit wider, and it opened down. 3x squared, so we're going to do the x squared first, and we would get negative 27, negative 12, negative 3, 0, 3, 12, and then 27. So 0, 0, 1, 3, negative 1, 3, and then 2, 12. So we'll just make it up here, and then negative 2, 12. And so notice this would be a sketch of that parabola. So notice the a was 3, so this parabola looks narrower than the normal parabola, and it opens up because a was positive. All right. So vertical shifts. What does it mean to have a vertical shift? Well, a vertical shift moves the graph up or down. So we have y equals x squared, and then we're going to subtract 3. So notice we graphed y equals x squared up here. So what is going to happen if I subtract 3 from all of those values? Well, if I plug in negative 3, remember we got 9. 9 minus 3 is 6. If I plug in 2, I would get 4. 4 minus 3 is 1. Plug in 1, I would get negative 2. Plug in 0, negative 3. Plug in 1, negative 2. Plug in 2, 1. Plug in 3, 6. So if I went to graph this, I would get 0, negative 3, 1, negative 2, oops, 1, negative 2, negative 1, negative 2, 2, 1, negative 2, 1, and then 3, 6. 1, 2, 3, 4, 5, 6, and then 3, 6. And so what happened to this parabola? Well, it's still that happy parabola, but notice this time the vertex moved down 3, so my vertex is now at the point 0, negative 3 instead of 0, 0. So that x squared minus 3, that minus 3 moves the entire parabola down 3. All right, so let's say we have y equals negative x squared plus 2. So notice a in this problem is negative 1, so the parabola should open down since it's negative, and that plus 2 should move the parabola up 2. Well, let's try. So we're going to do negative 1 times x squared and then plus 2. So again, do the exponents first. Negative 3 squared is 9. Then times negative 1 is negative 9. Plus 2 is negative 7. Negative 2 squared is 4. Times negative 1 is negative 4. Plus 2 is negative 2. And then we would get 1. We would get 2. We would get 1, negative 2, and 7. So if I went to graph this, I would have 0, 2, 1, 1, 1, negative 1. 2, negative 2, negative 2, 2, and then 3, negative 7, 1, 2, 3, 4, 5, 6, 7, and negative 3, negative 7. All right, so connect those. And notice it is a sad parabola, and its vertex is up top, so its vertex is at the point 0, 2. So that plus 2 moved the parabola up 2, and then the negative x squared made it open down. All right, so how do we find the vertex of a parabola without having to graph it? Well, there's a formula to find the vertex of a parabola. So you remember the quadratic formula? X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Well, if you get rid of the plus or minus square root term and you just take negative b over 2a, that's how you find the x-coordinate for the vertex. So the x-coordinate of the vertex, and remember the vertex is the highest point or the lowest point of the parabola. If you want to find the x-coordinate of the vertex, you take the opposite of b and divide it by 2a. And then once you find the x-coordinate, you can plug in that x-coordinate to find y. So you can plug in that x-coordinate to find the y-coordinate. So again, the x-coordinate of the vertex of a parabola, you use x equals the opposite of b over 2a. So find the vertex. Y equals x squared minus 8x plus 1. Well, we're going to use the formula x equals the opposite of b over 2a. And so my a is 1, my b is going to be negative 8. So my x-coordinate is going to be the opposite of b over 2a. So it'd be 8 over 2 times 1 is 2. So the x-coordinate of my vertex is going to be at 4. So I know my vertex is going to be at the point 4 something. Well, to figure out the y, I'm going to take that 4 and plug it into the equation. So y equals x squared minus 8x plus 1. So I'm going to take that 4 and plug it in for both of my x's. So y is going to equal 4 squared is 16 minus 8 times 4 is 32 and then plus 1. So y is going to equal negative 16 plus 1, which is negative 17. So the vertex of that parabola is going to be at the point 4, negative 17. And we can check on Desmos. So we can go on Desmos to graph this. Y equals x squared minus 8x plus 1. And then if I went to find the vertex, you can just tap on it and notice, oops, we got 4, negative 15. Oops, yes, because I'm adding 1. So that should be negative 15. That was just poor math by Miss Hefflinger. So negative 4, negative 15 is going to be where the vertex of that parabola is going to exist. All right, so y equals x squared minus 3x minus 4. If we want to find the vertex, we're going to use the formula x equals the opposite of b over 2a. So the a is going to be 1 and the b is negative 3. So it's going to be the opposite of b, so 3 over 2 times 1 is 2. So the x-coordinate for my vertex is going to be 1.5. And now we've got to find the y-coordinate. So y is going to equal 1.5 squared is 2.5 minus 3 times 1.5. So that would be 4.5. So minus 4.5 and then minus 4. And so this is going to be negative 8.5 minus 2.25. is going to give me 5, 2, so 6.25. So that my y-coordinate is going to be negative 6.25. So my vertex is going to be at the point 1.5, negative 6.25. So if I go to graph that, we get y equals x squared minus 3x, minus 3x, and then minus 4. And then I get 1.5, negative 6.25 for my vertex. So it looks like we found that right. So again, to find the vertex of a parabola, you use the vertex formula, which is the opposite of b over 2a, or it's the part of the quadratic formula without the square root. All right. The other key points to be able to graph a parabola are called the intercepts. So to find the intercepts of a parabola, remember to find x-intercepts. You're going to let y equal 0 and solve. And we're going to solve by factoring. To find the y-intercept of a parabola, you just let x equal 0, and then you're going to solve for y. Okay, so to find the intercepts of the parabola, let's start with our x-intercepts. So to find the x-intercepts, you're going to plug in 0 for y. So 0 equals x squared minus x minus 12. And then we're going to factor this. So multiply to negative 12, add to negative 1, and my intercepts are going to be x minus 4, x plus 3. So either x is equal to 4 or x is equal to negative 3. So those are going to be my x-intercepts. So the point 4, 0, and the point negative 3, 0 are going to be my x-intercepts. To find my y-intercept, you let x be 0. So I'm going to plug in 0 for all my x's. So 0 squared minus 0 minus 12. So my y-intercept is going to be when y is negative 12, or it's going to be at the point 0, negative 12. So those are going to be my 3 intercepts for that parabola. So let's go ahead and graph it and make sure that those are the intercepts. So we had y equals x squared minus x minus 12. So there's the parabola. And if we want to find intercepts, notice we have an intercept. It's going to cross the x-axis at negative 3, 0, and at 4, 0. And then my y-intercept is down here at 0, negative 12. So that worked. Factoring or the quadratic formula if they're not going to be pretty. So we have y equals x squared plus 4x minus 17. So to find x-intercepts, plug in 0 for y. So 0 equals x squared plus 4x minus 17. Notice we can't multiply to negative 17 and add to 4, so I'm going to have to use the quadratic formula. So x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And 17 times 4 would give me 68. So x is going to equal negative 4 plus or minus the square root of 68 over 2. And so now we're going to use our calculator to get approximate answers, because I don't know how to graph negative 4 plus square root 68 over 2. So negative 4, and we're going to take plus the square root of 68, plus the square root of 68, and then divide by 2. And so one of my x-intercepts is going to be 2.123. And then we're going to subtract the square root of 68. And my other x-intercept is going to be at negative 6.123. So those are going to be my 2 x-intercepts. To find the y-intercept, plug in 0 for x, and we would get y equals 0 squared plus 0 minus 17. So my y-intercept is going to be negative 17. So if I go to graph that, y equals x squared plus 4x minus 17. And I want to check the intercept. So notice I have an intercept. What happened? 8, 2. It's not just 68. Ms. Hefflinger is making some careless math mistakes, gentlemen. I apologize. So we have to do 68 plus 16. And so we would get 1484. So it's going to be the square root of 84. So if I did negative 4 plus the square root of 84, and then divide that by 2. One of my x-intercepts should be at 2.582. So we'll just do 2.58. And my other one, if I subtracted the square root of 84, I would get negative 6.58. And so now notice negative 6.583 and negative 2.583. And then my y-intercept is down here at negative 17. All right. So now let's use all of that information to be able to graph parabolas in the form ax squared plus bx plus c. So step 1, you're going to find the vertex. And remember, to find the vertex, you use opposite of b over 2a is going to give you the x-coordinate. And then you're going to plug that back in to find the y-coordinate. And then you find your x-intercepts by making y equals 0 and solving by either factoring or the quadratic formula. And then you find your y-intercept by letting x equal 0 and solving for y. So let's graph this first one, x squared minus 6x plus 8. So to find the vertex, x equals the opposite of b over 2a. So the x-coordinate for my vertex is 3. To find the y, plug 3 back in. So 3 squared minus 6 times 3 plus 8. So this would be 9 minus 18 plus 8, which would be negative 1. So my vertex is the point 3, negative 1. And then to find your x-intercepts, let y be 0. So 0 equals x squared minus 6x plus 8. Can you multiply to 8 and add to negative 6? Yep, it would be x minus 4, x minus 2 equals 0. So my 2 x-intercepts are 4 and 2. So it's going to cross the x-axis at positive 4 and positive 2. And then my vertex is the point 3, negative 1. My y-intercept, plug in 0 for all the x's, so 0 squared minus 0 plus 8. So my y-intercept is at 8, so 1, 2, 3, 4, 5, 6, 7, 8. And so if I connect those, here is a sketch of that parabola. So we can check on Desmos. So y equals x squared minus 6x plus 8. And notice there's our parabola. They look similar. So x-intercepts 2 and 4, those look right. Vertex at 3, -1, and y-intercept at 0, 8. All of those points look correct. All right, so we have y equals x squared minus 3x minus 4. Find the vertex. X equals the opposite of b over 2a. So my vertex is x coordinate is 1.5. The y coordinate is going to be 2.25 minus 4.5 minus 4. So -8.5 minus 2.25. Oops. And we get 6 points. So the vertex is going to be at the point 1.5, -6.25. My x-intercepts, let's see if this factors. So 0 equals x squared minus 3x minus 4. It does. So it would be x minus 4, x plus 1. So my two x-intercepts are going to be at 4 and -1. So at -1, +4. And then my vertex is at 1.5, 6.25. So 1, 2, 3, 4, 5, 6.25. And then the y-intercept, plug in 0 for all of the x's, and you would get 0 squared minus 0 minus 4. So my y-intercept is at -4. Oops, not positive 6.25, -6.25. 1, 2, 3, 4, 5, 6.25, and then -4 for my y-intercept. 1, 2, 3, 4, and there we go. And then connect these, and there is a sketch of that parabola. So we can check against Desmos. We got y equals x squared minus 3x minus 4. And so my x-intercepts are at 4 and -1. My y-intercepts at -4, and my vertex is at 1.5, -6.25. All right. So why don't you guys pause the video and try and graph the following two parabolas by finding the vertex, x-intercepts, and y-intercept. All right, so x equals the opposite of b over 2a. So this is going to be 1 over 2. So my vertex is going to be at 0.5, and then to find the y, we would get 0.25 minus 0.5 minus 12. So this would be -12.25. So my vertex is going to be at 0.5, -12.25. X-intercepts, we have 0 equals x squared minus x minus 12. So this would factor into x minus 4, x plus 3. So my x-intercepts are at 4 and -3. Y-intercept, plug in 0 for all the x's, and my y-intercept would be at -12. So 1, 2, 3, 4. 1, 2, 3. So 4 and -3 are my x-intercepts. And then at 1/2, -12.25, so down here. And then my x-intercept is at my y-intercept's at -12, so then connect these. And that would be a sketch of that parabola. We can check against Desmos. Y equals x squared minus x minus 12. Notice we have intercepts at -3 and -4. And then our vertex and y-intercept look to be right. So all of those points look to be correct. On the next one, y equals x squared plus 2x minus 5. So our vertex, the opposite of b over 2a. So my x-coordinate for my vertex is -1. Then the y-coordinate would be 1 minus 2 minus 5. So my y-coordinate would be at -6. So my vertex is going to be at the point -1, -6. My x-intercepts, we have 0 equals x squared plus 2x minus 5. I can't factor that, so I'm going to have to use the quadratic formula. So x equals -2 plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So my x-intercepts are going to be at -2 plus or minus the square root of 24 over 2. So now we're going to use a calculator to figure out the approximate answers. So -2 plus the square root of 24. and then divided by 2. So one of my x-intercepts should be at 1.45, and then subtract the square root of 24. And my other x-intercept should be at negative 3.45. My y-intercept, plug in 0 for the x's, and my y-intercept should be at negative 5. So let's do this. So negative 1, negative 6, 1, 2, 3, 4, 5, 6. There's my vertex. My y-intercept is at negative 5. My x-intercepts are at 1.45 and negative 3.45. And then if I connect those, there's a sketch of that parabola. So let's graph that. Y equals x squared plus 2x minus 5. And, y equals. And so we have our x-intercepts at negative 3.45, 1.45, y-intercept at negative 5, and my vertex at negative 1.6. All right, your homework is from 10.4. Let me know if you have any questions.